Hi, this is Callan Bentley. Welcome back for another smart figure. After watching this video, you should be able to distinguish between the crust and the lithosphere, two very important but not quite the same layers on planet Earth. First thing to keep in mind is that Earth is a layered planet. So you can classify the layers of Earth by their composition or by their physical properties, the way they behave. If you go by composition, of course, the layers are pretty simple. It's just the core, which is the metallic innermost layer of the Earth, the rocky mantle that surrounds that, and then a very, very thin layer at the top that's called the crust. On the other hand, you could classify Earth's layers in terms of how they behave. In this case, you get slightly more layers. There's an inner core, which is solid, an outer core, which is liquid, a lower mantle, which is relatively stiff and resistant to flow. On top of that is a layer called the asthenosphere that's relatively weak and it's relatively easy to flow. It's not magma, but it's still a solid that flows. And then on top of that is the lithosphere, which is mostly the outermost bit of the mantle, but it also includes the crust. So if we look at a zoomed-in cross-section of the outermost rocky layers of Earth, we see something that looks like this. Notice that you've got either oceanic crust or continental crust. So there's two flavors, if you want to think of them that way, of crust, and it's one or the other. Nowhere does the oceanic crust underlie the continental crust. A lot of people seem to make that mistake. So it's either continental crust or oceanic crust, and then underneath those kinds of crust is the mantle, all the way down to the core. Now, the distinction of how this relates to the lithosphere is that the lithosphere also includes that outermost bit of the mantle. So the oceanic lithosphere is the oceanic crust plus a thickness of lithospheric mantle that goes down to about 100 kilometers. So the mantle part of the lithosphere is actually like 9 times as thick as the oceanic crust part. Underneath the continents, it's the same story, where you've got continental crust, and then underneath it is this bit of the mantle that basically is stuck to the crust and moves around with it. Underneath the lithosphere, no matter where we look, is the asthenosphere. That's that solid but mobile portion of the mantle. We can see the relationship between crust and lithosphere at every kind of plate boundary. Here, for example, is the divergent plate boundary, where you've got the crust and then you've got mantle being added on underneath the crust to make the oceanic lithosphere. Notice that the mantle portion of the lithosphere is thinnest at the mid-ocean ridge itself, and it gets thicker as you travel away from that ridge. At a convergent plate boundary, we can see that we've got subducting oceanic lithosphere, only a very small portion of which is crust, most of which is lithospheric mantle. And then that's going down underneath an overriding plate. In this case, the overriding plate's leading edge is made out of continental lithosphere, the continental crust plus the lithospheric mantle underneath it. Okay, let's go back to this cross section again, and now's an opportunity for you to test yourself. Can you identify the different layers that are shown in this cross section? Go ahead and pause the video while you think about it, and when you think you've got them all, you can start it up again. Okay, welcome back. Hopefully what you got is that continental crust, the oceanic crust, the oceanic lithosphere, including the oceanic crust plus the underlying mantle, the continental lithosphere over here, and then basically what we have is the mantle all the way down and the asthenosphere from the base of the lithosphere down to the top of the lower mantle. Hopefully you got all those. Congratulations if so. That means you've mastered the difference between the crust and the lithosphere. This has been another Smart Figure. Thanks so much for your attention.